adult phase of this insect, so we had no idea what it looked like. We made some assumptions based on the others, and so these are actually corn rootworm emergence cages. I'm fortunate enough, Lance Mikey, who's the corn rootworm entomologist that's up, well, he's in Lincoln but works up at NREC, had 200 of these sitting around. He just built new ones. And so out of frustration, I tossed these out into an adjacent field at NREC, and within 24 hours, I started actually collecting adults. I wasn't 100% certain at the time these were the adults, so you didn't see anything published on this right away in CropWatch. But we sent these away for genetic analysis to compare with the maggots that were present and got a match. And so this is the adult phase. I'll blow it up to full screen so you can get an idea of the characteristics. Basically, we started collecting them. We collected all the way through to the 19th. I was pretty excited. This is when the greenhouse studies started. And then on the 19th, they stopped. And that was it. I took some that were actually still in the field, put them in a chamber, turned the degree day or the total day length back to what was mid-July, and got a few more to emerge, and that was it. So I called my collaborators in Japan and said they stopped emerging. I said the same thing happens with the related species they have there. So there's this diapause that they set into in the fall, and they overwinter what we assume to be as third instar larvae in some of these fields, and that's to be confirmed this spring. Even when I pulled the plants out and put a cage on top of bare ground where plants used to be, I still got adults emerging, less, but got adults emerging, which means they're pupating in the fields during the course of the summer. I put this up to remind myself they're very lethargic insect. They don't move around a lot when they emerge. So a lot of the other insects that we find and you catch in small vials, they'll bounce around inside that small vial with the heat and everything else that's around there. They're really irritated. This looks exactly like a mosquito. It just sits on the outside of that vial and doesn't move. So it's relatively easy to pull out of the vials, but that behavior is different than a lot of other things that we might see. So if we blow them up, they're 1/4 of an inch long. They're not really large insects by any means. That's from leg to leg. They have this black and white banded pattern. I have not seen anything else that remotely resembles this as an adult in the field. The unfortunate thing is that we probably don't have good scouting, general scouting techniques for finding the adults. They have that orange abdomen, and this is actually a female. You can see the ovipositor here. That's what they would use to lay eggs, probably right into the stems of the plant. I'll talk about that a little bit more. Classified as a new species, this is Raymond Gagnes, one of the USDA ARS researchers that is taxonomist that has given it this name. We'll be able to use that a lot more frequently as we get into April. So the genus, 56 species worldwide, including now Soybean Gall Midge. It's actually 16 species in the US. I keep forgetting to update the slide with it included. We have no reports of any species in this genus in the US attacking soybeans. We do have one in Japan, but it does not attack the same part of the plant. And that one was immediately compared with this one, and the genetic match was 8.5%, which means they're two distinct species from one another. So it raises a lot of challenges. I have another one down here. I put this one up. This is actually from Australia. This one attacks flax lilies. I just put it up because of the similarity of the adults to what we have for Soybean Gall Midge. This genus is very confined in terms of how similar the adults are. So just remember, in the US here, we have a number of other species that look very similar to this. We're not seeing them in our soybean fields, but it's something to be aware of. Most of them are on trees, prunus and other things. And so I get a lot of questions. Where did Soybean Gall Midge come from? Why did it suddenly show up? That question we don't have an answer to. Tamara showed some nice genetics work about bacteria coming to the country. I think that's some of our approaches in the future, is how diverse is this thing now that it's been in the US here, what we assume for a little while. Anybody have trouble sleeping at night? No? Wow. Okay. That's the first. Usually I get a few hands up that, okay, you guys sleep well. If you do end up having sleeping issues, I highly recommend this book, 700 pages. It'll take you a while to get through. Usually about 2 pages, you'll be out cold. But it is, Raymond put this book together, and it's a tremendous resource for trying to understand the genus that this insect belongs in. If you're really interested, you can skip all the way to page 462, where Rosilia is. Raymond sent me it, and I just emailed him back, what page is Rosilia on? Because I didn't want to do all the searching. It tells you that they're mainly found under bark or in flowering heads. In fact, one of the species that was discovered since 2003 in Japan is a pollinator. So just to show you how diverse that group is. We were lucky enough to get a pollinator, right? That would have been nice. You know, it spans 23 genera, 23 plant families. So what I'm telling you is that it has a broad host range, and that raises all kinds of questions about where else does soybean gall midge exist besides soybeans. Host plants are not known for 13 of the species. That's 5 in the U.S. We don't know what host they even live on. They got caught in flight while they were moving, and that's how the taxonomists have identified them. So there's a lot of holes to work out. 9 new species, as I mentioned earlier. These are globally. Russia's had 2, Africa's had a couple, South America's had some, the 1 in Australia and 2 in Japan. And so this has been an area that's been expanding for whatever reason for this particular genus. We assume about 2 to 3 generations per year on this. That'll be clarified this spring with some of the research efforts. We've got aggregated populations. I get a lot of questions on how well they fly. There's a closely related genus to this of a major economic pest in Japan, and that one has capabilities of flying at least 4 kilometers away from a source and infesting plants. So either they're blown by the wind, and in the process of being blown by the wind, they can direct themselves to a soybean plant. I'd be surprised if this one does that well, but the wind-blowing movement is probably a characteristic, and this was brought up at some of the roundtable discussions we had, so we'll be kind of focusing in on that. They lay eggs over a period of time, right at the base of the stem. We don't know how long this period is. Again, these are basic information that's really important to saying, like Dectes stem borer that I'll talk about, the complications is the egg laying period is quite long for that particular insect. Overwintering, probably in the soil, could be an alternative host of some kind. We would assume the 3rd instar, so that would put them in the field. But this is a really important factor because it does open up some potential management practices. There's a list of the plant families that are involved, and here's just the common names of some of those. And so, you know, although this is kind of a stretch getting out into this category, we'll look at these and see if we can find anything as we move forward. This is just to show you how many can show up and kind of some of the questions that we were asking ourselves going into this fall. I can send you this photo. You're welcome to count it. There's probably over 150 larvae on this plant, including the smaller ones. This is towards the end of the season. So a question, how many eggs can a female lay? Probably not 150 and probably not on a single plant. So likely more than one attack on this given plant. Whoa, just taking off, going back. There we go. And then how often those females lay eggs. So likely multiple attacks over a period of time. And those field distributions suggest that they kind of go to whatever's closest. Management practices, we got a chance to evaluate a non-replicated trial from 0.5 all the way through maturity group 4. Planted from late April through early June. Everything was infested in this. What I can't tell you is when the infestations occurred, right? So if we had 2 to 3 generations a year, maybe the later plantings were infested by a later emerging population, which would confuse some of that data. So we have research directed towards that because it would be nice to have some cultural practices beyond the insecticides that are likely going to be happening this spring. The landscape characteristics, heaviest damage was observed next to corn, last year's soybean field. This definitely points to the fact that it could be in the last year's soybean field, now last year's soybean field. And so this is a large question. Those emergence cages are going to go out pretty much on every point I've discussed, including the field borders. What's interesting about this particular insect is when it falls to the plant, the larvae flip themselves away from the plant. They get as far away as they can. They do that for a variety of reasons. Insects do it to get away from predators. If they all fell in one spot and huddled together, it'd be a pretty easy picking for some rabid beetle running around looking for a food source, so they get themselves away. Raymond's been asking the question, is it possible they can get themselves into the ditches and maybe that's a better overwintering site? We're asking questions about the residue that's in the field. Could that help with overwintering? And so again, there's going to be a lot of cages floating around this spring. Obviously, this highlights the uncut or dense brome ditches. So a lot of observations made on this year. As I was driving around the state, I took note on it. It seemed like when we had denser areas, we had issues. But just as I would come up with something, I'd end up visiting a field that showed the opposite. We had a particular case up in the Hardington area where they'd split the field in half. Half was corn, half was soybeans, no border in between. And they had a gradient coming out from where the cornfield was, which was last year's soybeans. And obviously, there's no dense vegetation for them to move directly into. So there are lots of things going on with this particular insect that we'll be trying to address. I'm going to spend a little bit of time here focusing on one particular field and looking at the yield impacts of this field to help us understand timing. Maturity group 3.8, planted on May 17th, so longer maturity group for a later planting date. Seeding rate of 150,000, no insecticides applied. We could talk about some of the observations across the survey and roundtable about insecticides. but there are certainly some challenges there. Again, this was soybeans the previous year. We took 5 transects in the field. Aaron Nygren was my contact for getting to this field. My students hate me for this slide, but we learned a lot. We collected a number of different data points. This comes from working with Roger Elmer over the years, trying to understand a little bit of the timing, but we did plant stands, standing plants. Really, the rest of these just highlight when things happen during the season, when the pressure's on for these particular plants. So regardless of soybean gall midge, this is the yield components of soybeans. If you're looking at soybeans, they're not as good as corn. Corn is a nice calendar for the year. When things happen, it's easy to kind of figure out when it happened, maybe not what happened, but when it happened. And we have in the same case in soybeans, things come on at a particular time, we'll develop nodes for a period of time, and then essentially we reach a point where they can't anymore. So looking at the yield components, we can determine if a yield component is impacted. Man, I keep hitting that button. If a yield component is impacted, like number of pods or number of seeds per pod, or total number of seeds per plant, it gives us highlight to things pressure still being on later in the season and not a one-time event, and then also seed size. So plant stand, based on the population of this plant and row space, about 80% survival, put us around 40 plants and 10 feet of row. We were under that, obviously, across the field as we moved out of the field, and it appears that it increased with distance into the field, which was just like the damage we were seeing. Of those plants that were there, only 56% of them were standing, so a lot of us are flashing back to Dectes stem borer and issues with losses on that. We took this data, we picked up everything, but we wanted to account for the possible mechanical issues that might occur in the field as a result of plants that had fallen over. Here's plant height and nodes. Really, they tell the exact same story, which is not too surprising. The most interesting part of this particular graph is the minimum number. You'd say, well, why the minimum number? Because it tells us when a plant ceased growth at a particular time during the earlier part of the season. If we assume soybean gall midge is the sole source of issues, that means at node 5 we had dead plants. They couldn't grow any more than node 5, which means they were infested prior to that date, right? So we used a soil water model developed by Jim Speck. We have planting date of May 17th. V3 stage was achieved by June 10th. I would assume that we at least need that much time to kill off these plants and cease growth. So we're looking at least the June 10th time frame, possibly a little bit before that, so that they would end up being dead. And remember, I was out at the end of June here, but I've had people report that in the mid part of June, they were seeing infestations pretty clearly in some fields that were out scouting. The other thing is the average here, just a continual increase, and some, as far as the maximum. So this just helps us understand with distance when the timings might have occurred. It appears things occurred first early, and then if you look, we get up to node 9 or 10 here. We're looking at later in the season, possibly as they got further out of the field, the frequency began to increase. Pods and seeds, this is really just getting the economics. We had issues with pod development a year at least, or pods having being retained up to about the first 50 feet. Once we got beyond that, things jumped up fairly quickly. I would assume that plants that weren't infested were actually overcompensating for the loss of a neighbor, so they were probably trying to compensate for some of that loss. That's the flexibility of the yield components I showed earlier. Number of seeds, we basically had no seeds, so we got to 50 feet. That's not the complete story. There are seeds there, and even at 100 feet here, it starts to look a bit better. But we have issues, obviously, with seed weights. So here's the seed weight data, 50 and 100 feet. 8,000 seeds per pound is astronomically high. This is stuff that goes back out of the back of a combine. It's not really retained or kept to be sold. So it's really at 200 feet where we start to pick up something that's in the normal or typical seed range, seed weight range. So that was just trying to complete that side of the story. And then you can really see it here, the yield loss estimates. We were losing 92% of our yield at 100 feet. This is one of the more heavily impacted fields that I saw. And so that's an important thing. The round table showed us that space, growers estimated that they lost across the two locations where we held us about 75% of their yield. So it's still a pretty decent amount of yield loss, significant amount of yield loss. And then they were up in that 15 to 20% range beyond that first 100 or 200 feet. So this is something that is definitely on everybody's radar. 2014, I'm going to show you 4 years of data here on a particular field. The grower that has this field worked with Aaron Hodgson's. He says, even though the yields don't show it super clear, in 2014 he began having just the very edge of the field, he was having issues. This is soybeans being flipped back and forth between these two fields. 2015, you can see it here, kind of just a little bit more along the edge. 2016 really progressed. On this part of the field, 17 had issues, and we'll get 18 here in a little bit. But so this has been building in some of these fields for a number of years. We have a couple places in the state like that. My concern is that the areas that look like 2014 that we saw last year, are they headed on this same track? And if so, how do we slow that down? Okay, things that don't work. I know many of you are planning on how to scout for this spring. This is the hard part. We put sticky traps out along with these emergence cages and caught nothing. I would look through them, could not find any adults. Either the adults get messed up by getting stuck to them, or they're just not contacting these cards. So that's unfortunate, because that would have been a good way to scout for them. Sweep nets, apparently if you have a four-wheeler and you want to drive along the edge, you may catch a couple in a four-wheeler. We don't know how that relates. I'm going to try and get a four-wheeler through a grant, because that would be fun. But it doesn't seem to relate very well, or we'll get an estimation of this. It also could be the time of day. So when we're out there sweeping relative to the 24-hour collection, right? These things never stop collecting. That they maybe are active during the night, or early in the day, or late in the evening. I was usually out there between about 9 o'clock through about 3 or 4 in the afternoon. Did seem to catch a lot. And then laying in the field, although very relaxing relative to looking at these, doesn't seem to yield any soybean gall midge. So you're welcome to do this. You'll get little insects crawling all over you, but you're not likely to see any soybean gall midge. Okay, so we're expecting areas to intensify, slow spread to new counties. Maybe the environmental conditions will pull some of this back. I've had a lot of people threaten, I'm going to go to corn. Don't change your farm operation. I'll have Julie Peterson or Tom Hunt or somebody else talking here about corn issues, or Tamara will be up here with a longer section on corn issues. So we don't want to change our farm operations. I think this is a manageable pest. It's going to take us a bit of time. But foliar applications are certainly a possibility. Border treatments near those 2018 fields. This is part of a greenhouse study that I ran. I infested at each stage, starting at VC, going all the way through to V3. V3 stage was the first time I got them to successfully infest the plants under wet conditions. I don't know if that'll hold up, but this will be something that we're really focusing on in the field and greenhouse. And then what we're really hoping that a lot of you will do, will base your application on the soybean gall midge adult activity. And so we're going to be monitoring this in a number of different places in the eastern part of the state. We'll be posting this through Twitter and on Crop Watch. And this is probably where you're going to get the return on that insecticide if we do have significant pressure from soybean gall midge. And so what I saw was a lot of applications occurring based on calendar date last year for people who had issues, and it wasn't paying off. They said it doesn't work. I said it's because we don't know when the adults are moving. So we need to use that type of data, I think, to get some decent efficacy. So we're tracking adult movement beginning in March, way ahead of when any of you are planting. We want to know when they first emerge. We're looking at the source, the number of generations. We're doing a number of experimental trials with insecticides, both with a large focus on what's commercially available, as well as some experimentals that may be able to come to the market. We're using a sentinel plant system, which is basically I grow plants in a greenhouse, put them on the field for 1 week, and that tells me the potential for them to infest those plants throughout the course of the season. Will give us an idea of the potential risk and threat. We're evaluating some cultural control practices, looking at planting date and tillage. Nobody likes the word tillage, or a lot of people don't. But if they're overwintering in our fields, and tillage in the fall may be something that could help with something like this. That'll need to get a handle. We're doing length of life cycle, healthy versus damaged plants, plant stage, and a number of other things in the greenhouse to try and get a handle on that side. Okay, questions on soybean gall midge? I went through that really fast. No questions. That's awesome. Oh yeah. Doesn't look like it. Again, these are things that were evaluated indirectly, but we had a number of fields we were at that did have seed treatments that didn't appear to have much of an effect. It could be the season, wetter than normal, reduces the long-term efficacy of some of those, so that may have dialed off before, whereas previously it may. I know a number of the insecticides trials we're running have that as part of the treatment set, so we'll have a better handle on it this spring. Good question.
The corn and soybean field, are they going to winter back in the corn stubble, or winter in the bean stubble?
They're going to be in the bean stubble from what we assume right now, but we're literally taking that exact pairing you described and putting cages in both.
So if you do some tillage, you would till the bean stubble?
You till last year's bean stubble. When you harvested, that would be the stuff that I would, right now, based on what we know, target to take out. The corn stubble, we don't assume that. Now, I could be totally wrong, and those of you that have heard me talk, I say that this entire presentation is subject to change without notice because we're learning as we go. But there's pretty confident in terms of the evidence, probably overwintering right in our last year's soybean fields. We are putting together a protocol to actually scoop off the top couple inches, bring those in the greenhouse, warm those up in advance, and get adult emergence from those to clarify prior to making decisions in the spring on whether or not that they would be coming from that. Yeah, Bill.
So do you think the larvae are in the stubble overwintering, or you were saying that they roll out and they roll into the area? So
yeah,
so I'm just wondering if you do tillage, is it gonna, are we doing tillage to break up the residue, or are you just trying to
disrupt the larvae in the soil? Yeah, so they've abandoned the plant. We saw that during the season. As the plants die off, they're vacant of all insect activity. You don't find any more midges in them. They've fallen out, and the indication from the genus is that they tend to fall out and then move away and then move down to the soil. About 2 inches is what we assume. So this gets into Dectes territory and managing Dectes, which does overwinter in the actual plant itself. So good question.
do they winter in the brome? Will they winter in the brome?
We don't know. We did get some people sent in samples that there were so few we couldn't do much with them that had an orange larvae on brome grass, which may or may not be associated with this at all. But it's probably that they're mostly in our soybean fields. Maybe it's the environmental conditions that might be favored by survival in a denser canopy or area. So that's one to be fleshed out with the cages, as well as the relative emergence on the border. Just remember, if you're making applications, the 01 category for egg does not cover that ditch. So that's a different category. That's the 07 category. So just be careful you don't get into trouble trying to make any applications in those zones. That's the right-of-way classification or whatever for that. So I've got that question before. Other questions? Yes, Bill.
I got one other. If we were to put some of these rootworm traps out to try to catch adults,
yep.
You don't have any correlation that would say, okay, if we catch 10 of these in a night, then we know this is a good time to spray. Yeah. We're just collecting data for you for future.
Yeah. So what we're initially going to do and how our insecticide trials are set up is that when we catch the first emergence, we're going to make our application. We don't know when peak emergence occurs, but we'll make that first application for an insecticide. My wife's the insect toxicologist in town, so she wants to study the behavior and deterrence of some insecticides to see if that pertains to longer efficacy and control. But basically the goal is to say, oh, there's activity, so if we were going to spray, at least we're in the activity zone. And then as we continue to collect, as the population continues to rise, we would, on our trials, make a second application. The ultimate goal with that data is to line it up on a degree day model, so lots of other insects have degree day models. This takes it away from what we collect to each farm as an individual or area as an individual to say, when will we expect emergence to occur? So this is a 4-state effort using these cages, and that'll help hammer out the data fairly quickly as to some sort of model that'll need to be validated. So it's a rather archaic approach right now, but it's probably the best thing we have considering the applications didn't work very well on the others. Other questions? Yeah.
You said you're just spraying insecticide. You didn't spray insecticide long residual.
We've got the whole range. I think I don't know what hasn't been tossed across my desk at this point as far as a potential. Some are just numbers because they're. So people ask me what insecticide to apply, and you know, and your agronomist can probably give you as good advice as we can until we actually see these things in action. But you know, your organophosphates, pyrethroids, carbamates, you look through that weed guide, you'll see lots of potential opportunities. Pyrethroids tend to have longer residuals, so that may be where some people go. Some people have already achieved a 2EE label, which is an emergency label for the use of a given product, but those were back, I think they came out in June and July. I would caution following those because we didn't see any adults yet, so we couldn't base this on adult activity to be indirect evidence. We did have some applications occur that did appear to knock down populations, so we know some things will work. It's just probably the timing is more important than anything else. The products will flesh themselves out this spring in terms of their efficacy. Other questions? You guys are good at asking questions. Yes, Bill.
I know we was talking about foliar applications of insecticides, but what if we were to take like a Cruiser Max and add more Cruiser to it with the systemic activity? Is that an option for even that 100 feet or that 50 feet?
We have no idea at this point whether or not that'll make any difference whatsoever. I know there are rates included in those treatments that they're planning to apply. There's been discussion of banding on some insecticides, a foliar, or like, you know, in furrow application as well. And so I think there's a lot of kind of kitchen sink related potential applications. I would caution growers from doing that until we kind of learn how those work. You know, you load up that part of the system that early, and I may be invited back here to talk about the issues of spraying early, broad spectrum, and with a lot of different products, we may have other issues as well. So it's a give and take. I understand the frustration that's probably out here, but we'll know a lot more after we get through this spring. We do have a calendar date based application if we don't see activity, because maybe we missed the target on where they're at. So I suggest following Crop Watch. That's where we'll be leading a lot of this information through. Other questions? I'll get to Dectes really quick. How are we doing on time, Bill? Do I have time to cover this?
We're fine. We're not here yet.
Okay. Okay, great. Well, food's here. I'm in trouble. All right, so Dectes stem borer. There is issues with Dectes stem borer. It kind of pops up. It depends on the frequency of infestation in the field. This one we have more information, obviously, in Soybean Gall Midge. The adults, you know, about a ½ inch long. They've got these long antennae. They fit in the family Cerebicity. That's why they get that longhorn beetle is the common name they're called. They're native to North America, historically on sunflowers, but they've shifted to soybeans. They did that in 1968. They got to the Kansas border, and unfortunately with Soybean Gall Midge, I think we got a lot better handle on how far they were up into the northern part of the state. As people were looking for Soybean Gall Midge, I was basically getting photos of Dectes stem borer, so it's a nice thing to accompany on a presentation. But I think they go relatively unnoticed in a field until the frequency gets high enough in the field for infestation. We start seeing lodging issues, and then sorting out why we're getting those lodging issues is sometimes when it pops up. Here's just as they enter the main stem. I'll go through the life cycle. Essentially, they start in the petiole, work their way down to the main stem as we progress through the season. So adults emerge in mid to late June. You know, they after emergence, they you know, have an oviposition or mating period. It's about 1 to 2 weeks in length. They live for a really long period of time. This is a lab study that was done down in Kansas. They live for about 56 days. That's something we will do with Soybean Gall Midge, and then they lay approximately 33 eggs. So I got a lot of questions on, do we have a chemistry yet that we can throw against these? It's really hard because they're out for so long. There is some Kansas data that shows that you can get some efficacy. It's just maybe not as economical. Here's the eggs. Essentially what the females do is they kind of pick out a bit of tissue on the petiole. They burrow out a little area and they lay the egg, a single egg, into that area. The eggs hatch in about 5 to 7 days. Then they burrow down that petiole. They spend about 2 weeks in that petiole, kind of working their way back and forth, and then they'll actually go into the main stem. This is usually occurring, you know, in that August time period once they get into the main part of the stem. So that's really when scouting becomes an opportunity, and it's more to gear you towards harvest and avoiding a lot of harvest losses. You know, plant senescence obviously triggers them to overwinter in a chamber. You'll only really find one. It's possible to find maybe 2 in a single plant earlier in the season, but they're cannibalistic, so they'll kill one another. So it's a slight bit of satisfaction that only one of them makes it and the other one will die, right? Entomologists, we like that. The good news, yeah, I gotta have a bit of good news, right? But they'll work their way down. They turn around about 2 inches off the soil surface. They'll essentially start girdling out the area around it. They don't do this in sunflowers because the stalks are so big, and so they can't actually cut off a sunflower stalk. It's pretty hard. And if your soybean stems were bigger than a ½ inch, they probably won't be able to cut it off either. That's a breeding effort that'll be a little bit difficult. But you know, essentially they're creating this little overwintering chamber. That is an opportunity for some management to disrupt that habitat for them and reduce their overwintering survival. So this is some data from Zach Rystrom. Zach's actually one of my technologists that works up at NREC. He's a project coordinator up there. Zach did this work with Bob Wright, and this is just 2 emergence curves for 2013 and 14. The reason I put this up is to show you the span of the emergence, and if you look at insecticide data, this is where it becomes troubling, is the emergence period can occur, you know, between 70 and 190 days during the year, that period of 20 days. And so it can complicate the ability to actually get a lot of the adults in the application. The other thing is that the eggs laid, mean eggs per 5 plants, varies over the weeks after initial infestation. So you can see that we do get some 2, 3, 4, 5, 6. So that's the trouble with an insect like this, is it lays eggs over a very long period of time, making it difficult to manage. So what we're looking for really is a wilted leaf amongst an otherwise healthy canopy. You can do this right at the field edge. They're relatively poor flyers, so they tend to target things that are fairly close. You can do this in mid to late August. That's the time period I would target, and look for the percentage of damaged plants. So the more damaged plants you see, those are the areas you want to prioritize for harvest. And you're kind of looking at this threshold of about 50% of those plants being impacted. That's getting into that high risk category of the mechanical losses. There are lots of data out there that varies between, depending on what source you're looking at, that says that the burrowing, the process of actually feeding inside the plant, could cause significant losses. It varies between 1 and 15%. The majority of those losses occur because of the inability to actually pick up the plant at harvest. And so prioritize those heavily damaged areas. You're looking at those petioles, you can rip them off. Healthy petiole on the bottom, infested on the top here. That's the frass as they feed. What they kick out the back as they go is this kind of darkened tissue that you'll see. And splitting that main stem open, usually you can find. So I mentioned 1 to 15% yield loss. Lots of late season lodging is the major issue. This gets back into Tyler's territory, the weather. Weather. If we have a nice fall, we get out early and do things, we really don't run into issues with this type of thing. But if we get delayed and things sit for a while, then we get a greater chance of potentially having some issues. In particular, an early planting date with an early maturing variety is probably the worst case scenario for this particular insect because you have that greater chance of lodging. And so that's one of those characteristics. Another thing is burrowing the soybean residue. I think it's South Carolina has some data where they turned it in by 2 inches. So they did a 2-inch disruption with a disc. And that seemed to work in the fall. Weed control, targeting some of the preferred hosts. I got ragweed twice. The common cockleburr's the other one. I try. Sunflower is actually a preferred host for this. So although you get a lot of talk in the coffee shop, you really got an issue with these. You plant sunflowers, go to the sunflowers before they go to soybeans. So you create a trap crop potentially for them. Chemical treatments, which a lot of us, I think, would wish that we had something. They're really difficult and ineffective because they spend most of their time inside the plant, and that's really hard. People have mentioned like fipronil. That's not registered for soybeans. It was effective, but it's never been registered and is unlikely to because of the avian toxicity it has. But larvae are in the soybeans, extended adult activity, multiple applications. That's what the Kansas data showed. 2 applications over the course of a season. They were getting between 46 and 75% knockdown or efficacy on those trials, but it was getting difficult to justify the cost of that. And then prioritizing those fields. I mentioned this because that's probably the best tactic we have right now. So I think I spent 45 minutes telling you things that will hopefully work, but maybe not the best things that you wanted to hear. This is Crop Watch, Market Journal. Your Nebraska Soybean Board checkoff. You should thank a Nebraska Soybean Board member when you get a chance because they stepped up. We came in with a proposal after all the proposals were due and said we have a major problem on our hands, and the board dug money out that they weren't intending to use and gave it to us to work on this. And in fact, on the North Central Soybean Research Multi-State Program, our board said we'll fund every state if necessary to make sure we can gain way on this. They were the first ones to do that. And so I find that very helpful as a researcher that they've been so proactive in trying to get a handle on this. We don't want to tax our board too much. We want to get to other funding sources. That's what the petition is for. So signing that petition is really critical. It shows your need in the state. We're doing this across all 4 states. We really want to overwhelm the funding groups to say this is a major issue that needs to be funded. You follow me on Twitter. That's where I'll be posting a lot of stuff this spring. Send me an email. Sign up for Crop Watch. That's how we'll keep you up to date as we move forward. That's what I have. I went through it fairly quickly. So trying to keep us on schedule.
Everybody, and anybody else have questions for Justin?